Hello my dear student, today we are going to start a new chapter, that is General Organic Chemistry. The question related to this topic is asked every year in JEE Mains and JEE Advanced. Firstly, we will see that what are the topics and subtopics that we are going to read in this chapter. So, firstly we will talk about the electronic effect and we will talk about the steric effect. In electronic effect, we will see the subtopic, that is inductive effect, mesomeric effect, hyperconjugation, aromaticity and electromeric effect. Under this steric effect, we will talk about the SIR, that is steric inhibition in resonance, and SIP, that is steric inhibition in protonation. One thing that you need to remember is that this steric effect is going to be major and dominating effect in comparison to this electronic effect while doing the question. Now, let's start the topic, that is electronic effect. So basically electronic effect, or we can call it as electron displacement effect, it is going to occur through the bond. Okay, so electronic effect are mainly of these type. One is inductive effect, second one is mesomeric effect, we can call it as resonance effect as well as, third one is electromeric effect, and fourth one is hyperconjugation. Now this inductive effect is going to occur through the sigma bond, and this mesomeric and electromeric effect will occur through the pi bond, and hyperconjugation is occur by both the sigma and pi bond. So firstly we will start with the inductive effect. Before starting the inductive effect, we will talk about the electronegativity, because the question that we are going to do in the inductive effect is based on the electronegativity. The concept that we are going to use there is electronegativity. So what is basically electronegativity? What we have learned in periodic table and periodicity, that it is a tendency to attract shared pair of electrons. Suppose I am taking a compound as AB, okay, AB is a compound and there is a bond between A and B, and one bond is going to form by 2 electrons. And what I am supposing here, that electronegativity of B is greater than A. So what do you mean by electronegativity of B? So this B is going to displace these electron towards itself. Okay, so because of this electronegativity only, there will be delta negative charge over B and delta positive charge over the A. So this tendency of B to attract this shared pair of electron towards itself is called as electronegativity. Now this concept of electronegativity we are going to apply on covalent bond, and mainly we are going to apply on the sigma bond. We are not going to apply this concept of electronegativity on the pi bond. Now when we talk about the inductive effect, mainly we will talk about the modified electronegativity of the key element. Now what is this modified electronegativity and what is this key element? First let's talk about this. For example, if I am taking any group, okay, I am taking OH. So did I will consider the electronegativity of OH? No, I will not consider the electronegativity of OH. What I will consider? I will consider the electronegativity of this oxygen atom that is present here. Okay, it is attached here with a chain and it is attached with the hydrogen here. So I will consider the electronegativity of this oxygen atom. Okay, so what is the key element here? The key element is oxygen here. So in inductive effect, what we are going to consider? We are going to consider the modified electronegativity of key element. Now what are the factors on which this electronegativity is going to depend? So first we will talk about the charge. Okay, so if any species is more electron deficient, I can say that it have more tendency to attract the electron, means its electronegativity is going to be higher. And if any species is less electron deficient, it has less tendency to attract the electron, means its electronegativity is going to be low. So on the basis of charge, how I am going to tell the electronegativity? That if delta positive charge is going to be more, what I will say, that electronegativity is going to be more. If delta positive charge is less, what I will say, that electronegativity is going to be less. Now for the same element, I can tell the electronegativity on the basis of hybridization as well as. Suppose I am taking an element that is carbon. I am taking carbon sp, I am taking carbon sp2 and I am taking carbon sp3. Tell me which one is going to be most electronegative? We know that electronegativity is directly proportional to percentage S character. We have read in the chemical bonding chapter. So what I can say here, that carbon sp is more electronegative than carbon sp2 and then carbon sp3. So when I am taking about the same element, what I can say that sp hybridization is going to be more electronegative in comparison to sp2, and sp2 is going to be more electronegative in comparison to the sp3. Now third is bond angle. On the basis of the bond angle also I can tell the electronegativity, okay, how electronegativity is going to depend on the bond angle. So if I talk about sp hybridization and sp2 hybridization, tell me whose bond angle is greater. I know that bond angle of sp is going to be greater in comparison to sp2, means theta of sp is greater. So can I say that theta is directly proportional to percentage S character? Yes. So theta is directly proportional to percentage S character, and I can say that percentage S character is directly proportional to electronegativity. So where the theta is going to be more, electronegativity is going to be more. So what are the factors on which this electronegativity is going to depend? That is charge. We can tell by the charge. More positive charge, more electronegative. Hybridization, sp hybridization is maximum, then sp2 and then sp3. Then bond angle is directly proportional to the electronegativity. Now next thing, that in periodicity chapter we have talked about the elemental electronegativity, that when we go along the period, okay, means from left to right, what is happening there, that electronegativity is going to increase. So if they give you to compare the electronegativity of fluorine, oxygen, nitrogen and carbon, what I can say, that fluorine have the maximum electronegativity, then oxygen, then nitrogen and then carbon. Same as it is down the group, what is there, that electronegativity decreases. So maximum electronegativity is of fluorine, then chlorine, then bromine and then iodine. Now there is a topic that is modified electronegativity. This is important for the inductive effect, okay. So what we know till now, that when I talking about the same element, for example carbon, so always sp hybridized carbon is more electronegative than the sp2 hybridized carbon and then sp3 hybridized carbon. But what you have to notice here, focus here, that nitrogen sp3 is going to be less electronegative in comparison to carbon sp. Always remember this point, okay, that nitrogen sp3 is going to be less electronegative than carbon sp. And here you will notice that oxygen sp3 is going to be less electronegative than nitrogen sp, okay. So remember these 2 points. Now these are the questions which we have to do. So here in this question we have to compare the electronegativity of these group, okay. So how we are going to compare the electronegativity? Before doing this question, I have a question for you guys, that is that tell me the electronegativity of this, that suppose we have A positive, means there is proper positive charge over it, okay, complete positive charge, and here we have delta positive, A delta positive, A is neutral, here we have A delta negative and A complete negative. Tell me whose electronegativity is going to be maximum. What was the concept? That where the electron deficiency is going to be maximum, their electronegativity is going to be maximum. So where the electron deficiency is maximum, that is of A positive, okay. So whose electronegativity is going to be maximum, that is A positive. Then what will come, A delta positive, then neutral, then A delta negative and then A negative. So whenever you are going to solve the question of the electronegativity, okay, so just go through these concepts. Now let's do this question, that they have asked to compare the electronegativity of these elements, okay. So here we have NH3 positive and here we have NH minus and we have NO2, NH2 and NF2. Now where there is complete positive charge, first say this. So here NH3 is going to have the complete positive charge, means definitely the electronegativity of A, that is NH3 positive, is going to be maximum, okay. The electronegativity of NH3 positive is maximum. Now what will be the last one is is going to be NH minus only. So D is going to be the last one. Let's compare between NO2, NH2 and NF2. So what we have read in chemical bonding chapter, how the structure of NO2 is there, that there will be N double bond O and this is O. Okay, this is attached with any chain. So here there will be positive formal charge and here there is negative formal charge. So after this what will come? A delta positive. So after NH3 positive, what is going to come? NO2 is going to come here. Now next one, that negative charge species is going to have the least electronegativity. So NH minus is going to come at the end. Okay, this is the structure of NO2. I will make it again for you guys. So it is positive and this is negative. Now I have to compare between NH2 and NF2. Okay, tell me which is more electronegative, hydrogen or fluorine? We know that fluorine is more electronegative. So which is going to be most electronegative here? After NO2, that will be NF2, and later on what will come? NH2 will come. So this is the answer for this question. Let's do the next question. That is, we have to compare the same electronegativity between C double bond O, H, CHO you can say it, and CH2F. Now what you will see here, that in A, there is partial positive charge over carbon. We can draw a partial positive charge over here. And oxygen will have the partial negative charge here. Okay. So partial positive charge carbon is going to be more electronegative in comparison to the neutral carbon. Here you will notice that partial A positive is going to be more electronegative in comparison to the neutral one. So what will come here? Here CHO will be more electronegative in comparison to the CH2F. Okay, so this will be the answer for the second question. Now we will start the inductive effect. So first, basically, what is inductive effect? Okay. So when I make a carbon chain like this, 1 carbon, 2 carbon, and this is the 3rd carbon. Tell me whether it is polar or non-polar. Can I see the polarity here? No, there is no polarity. But when I'm going to add a group, for example, I'm adding OH group here. So what will happen? That I know that the electronegativity of oxygen is going to greater than the carbon. So what will oxygen do? That it is going to withdraw the electron from the carbon. And if it is withdrawing the electron from the carbon, here what will come? Delta negative charge is going to come over the oxygen. And carbon will have the delta positive charge. Okay. Now we know that carbon delta positive is more electronegative than the carbon neutral. This carbon delta positive will be more electronegative than carbon neutral. We have seen here that A delta positive is more electronegative than neutral A. Okay. So carbon delta positive is more electronegative than neutral carbon. So it is also going to withdraw the electron from here. It will withdraw the electron from here. So what will be there? Here also partial positive charge is going to come. Okay. Now what will happen here? Again this carbon partial positive charge is more electronegative than neutral. So again here partial delta positive charge will come over the carbon. So now what you will see, that because of the presence of this OH group, the polarity is going to be induced on this carbon chain. What is happening here? That because of this presence of OH group, the polarity is going to induce over this carbon chain. So this type of effect is called as inductive effect. So what is basically inductive effect? That it is going to induce polarity through the bond. Through these bond, what is happening here? That it is inducing polarity. Now what can be two possibilities here? The group that we are going to attach to carbon could be more electronegative than the carbon, or it could be less electronegative than the carbon. So I am taking the first condition where the group is going to be more electronegative than the carbon. Okay. So here I am attaching a group that is more electronegative than carbon. So what will happen here? So it is going to withdraw the electron from the carbon. So delta negative charge is going to come over the group. and delta positive charge will come over the carbon. Again, this delta positive carbon is more electronegative. It is going to withdraw the electron from here, and a smaller delta positive charge is going to come over this carbon. Now again it is going to withdraw the electron, and more smaller delta positive charge will come over this carbon. So what is happening here, that if the group attached to carbon is going to be more electronegative than it, so what it is doing, it is going to withdraw the electron density. And if it is going to withdraw the electron density, what we will call it as, we will call it as minus I group, and the effect is called as minus I effect. Okay, the next condition which could be possible here, that the electronegativity of group is going to be less than carbon. Okay, the group we are attaching here with the carbon can be less electronegative than carbon. So now which is more electronegative? Carbon is here more electronegative. So which is going to withdraw the electron? Obviously carbon is going to withdraw the electron. So carbon will withdraw electron this time. So what will be there? Over carbon there will be delta negative charge, and over the group what will be there? Delta positive charge. Again what will happen? That we know that carbon neutral is more electronegative than carbon delta negative. Okay, so it is going to withdraw the electron here. A smaller delta negative charge is going to present. Now again it will withdraw the electron, and more smaller delta negative charge is going to occur over it. Okay, so whenever a group which is less electronegative than carbon is going to attach like this, what I can say, that this group is going to donate the electron. What is doing here? That it is donating the electron to this carbon chain. So it is donating the electron density. So this group will be called as plus I group, and the effect is called as plus I effect. Okay, now few of the information about this inductive effect. This inductive effect is weak electronic displacement effect. In this statement type of question, they can ask you that whether inductive effect is a strong effect or it is a weak effect. So what it is a weak electronic displacement effect. Second one is that it is going to occur through the sigma bond. It is not going to occur through pi bond. It is going to occur through the sigma bond, and it is a permanent effect. Okay, they can give you a question that whether it is a permanent effect or temporary effect. So inductive effect is a permanent effect, and it is going to depend on the distance. What is there? That with the distance, if we are going to increase the distance, the inductive effect is going to decrease. So what I can say here, that I effect is inversely proportional to distance. Okay, that if you are going to increase the distance, inductive effect is going to decrease. Now the key concept that we are going to use here to solve all the question, that is going to be electronegativity, and this inductive effect is going to applicable up to 3,4 carbon. Okay, so first we will see the plus I effect. First what we are seeing, plus I effect. Okay, so plus I effect. So in plus I effect, what is the group? The group is going to donate the electron pair. We have already donate the electrons. Okay, the carbon is going to withdraw the electron from the group, or you can say the group is going to donate the electron. Now we will talk about the plus I group, that what are the groups which can show the plus I. So what are these groups? First, we are talking in reference to any atom. For example, here we are taking the reference of carbon, that this G is attached with the carbon. Means this G, for minus I, this G should be more electronegative than this carbon. Okay, and this G should be less electronegative than this carbon. So with reference to the atom we are talking. So deuterium and tritium will act as a plus I effect. They will show the plus I effect. Okay, and then anionic group like O negative, NH minus, NH2 minus, C double bond O negative, these will also act as a plus I group. Then alkyl group like CH3, primary carbon, secondary carbon, tertiary carbon, these will show the plus I effect. Okay, and the groups which are less electronegative, for example SiR3 and MgR, they will act as a plus I group. Okay, now we will compare the power, plus I power between these groups. So firstly we will talk about the alkyl group, then we will talk about isotopic, then we will talk about the anionic group, and then we will talk about the low electronegative species. So first we will see the alkyl group, how we are going to compare the plus I effect of the alkyl group. So one thing is there, that plus I effect is inversely proportional to distance. When the distance is going to be more, plus I effect is going to be less. Okay. So for example, I am taking here this example that here there is C double bond O. So what I can write here, that there is delta positive and there is delta negative. Here I can write delta positive and here there is delta negative. So what does this CH3 group will act? It will show the plus I effect. This CH3 will also show the plus I effect. In which direction this CH3 is going to donate the electron? This will donate the electron towards C double bond OH. And this will also donate the electron towards C double bond OH. Now the question is that between A and B, between these two, which is going to show more inductive effect? Okay. So if we see from this point, which is going to be nearer? So if we see this CH3 group is present at less distance in comparison to this CH3 group. Okay. So which is going to show more inductive effect? B is going to show more plus I effect in comparison to A. So plus I of B is going to be greater than the A. Okay. The next thing, that for alkyl group we are going to see the branching, and the plus I effect is directly proportional to the branching. More the branching, more will be the plus I. Okay, remember this. So if we see these three examples, here we have a straight chain, here we have a branching, okay, and here we have a 3-degree carbon. So now tell me where the branching is maximum. That is maximum in the case of the C, then in the case of the B, and then in the case of the A. So where the inductive effect plus I is going to be maximum? That is maximum in the case of C, then B, and then A. Okay. Third one, that plus I is directly proportional to the number of carbon. More the number of carbon, more will be the plus I. Example is that here we have taken 1 carbon, here we have taken 2 carbon, and here we have taken 3 carbon. So where the plus I is going to be the maximum? That is in the case of C, where the carbon number are maximum, then B, and then A. Now we will do the question where they will give question like this, that here you have to compare the plus I effect of these group. Okay, so if I see this question, how many carbon atoms are there? Here we have 6 carbon atom, and here we have 4 carbon atom. But if you see, the branching of B is greater than the A. So now what we have to do in these type of question? So always remember the priority order, that first we have to give the priority to the distance, means at which carbon or at which distance this plus I groups are attached. Okay, then we have give priority to the branching, means 3 degree will be greater than 2 degree and then 1 degree, and then we have to give the priority to the number of carbon. So if you see the first question, here we have 6 carbon and here we have 4 carbon, but we will give priority to the branching. Okay, here it is 3 degree, this is more branched, so whose plus I is going to be greater? B plus I is going to be greater than the A. Let's do the next question. So in the next question, what we have, that these groups are going to be attached and these all groups act as a plus I group. Okay, so let's see this. So here, let's first okay, now let's see the question. Okay, so what we have to do here in this question, so what is our priority order? First is distance, second is the branching, and third is the number of carbon. So if we see where the distance is minimum, okay, so here if you see, these are at the third number of carbon, here you see it is at the first carbon, here you see it is at the first carbon, here you see it is at the second, and here CH3 is at the first carbon. So definitely the answer will be between B, E, and C. Okay, now distance is done. Now we have to see the branching. So where the branching is maximum? That is in the case of the C. So where the plus I is going to be maximum? Plus I will be maximum for the C. Okay, in the case of C, plus I is going to be maximum here. Plus I will be maximum in the case of C. Now we have to compare between B and E. So if you see here, that on first carbon there is CH3 group. Here on first carbon there is CH3 group, but there is CH3 group over the second carbon as well as. So after C what will be there? There will be E, and after E what will be there? There will be B. Now we will compare between A and D. So if you see here, first we have to give the priority to the distance. Here methyl group is at the third carbon and here methyl group is at the second carbon. So on the basis of the distance, after B what is going to come? D, and then A is going to come. So this is the priority for the plus I groups. Okay, means this is how we have to do the question of the plus I. Now we will see the anionic group, that how we are going to do the question if they will give you the anionic group. Anionic group means groups which are going to have the negative charge over it. Okay, they are going to be electron rich compound. So now we know that where the donating power is going to be more, that is going to be act as more plus side power. Okay, so what I can tell here, that anionic group is inversely proportional to electronegativity. The plus I effect of anionic group will be inversely proportional to the electronegativity and directly proportional to the donating power. Means when I talk about the anionic group, if the electronegativity is going to be high, means it is not going to donate the electron, and if it is not going to donate the electron, I can say that plus I is going to be less. Okay, whereas if the electronegativity is going to be low, so what I can say, that donating tendency is going to be high, donating power is going to be high, so plus I is going to be high. So how we have to do the question of the anionic group, that is the plus I power of anionic group is inversely proportional to the electronegativity and it is going to directly proportional to the donating power. Means less the electronegativity, more will be the donating power and more is going to be the plus I effect. Okay. So if we have these four questions, so tell me whose electronegativity is minimum here. So here CH3, NH minus, O minus and C double bond O minus. Okay, so firstly we will talk about A, B and C. I know that carbon is going to be least electronegative. So plus I of A is going to be maximum. A is going to be maximum. Then nitrogen, then oxygen C, and then what will come? D. Why D is coming at the end? Because here the negative charge will involve in the resonance. Okay, so that's why it is not that much available for the donation. So what will be the answer for the plus I power? That is maximum electron is going to donated by the CH2 negative, then NH minus, then O negative, and then it is COO minus. Next, we will talk about the neutral groups. Neutral groups, what we have? That we have MgCH3 and we have SiMe3. Okay, I am taking as methyl CH3. So tell me which is metal here. Okay, so Mg is of S block. So what I can say that it has better tendency, more tendency to donate the electron. Okay, so whose electronegativity will be greater? Silicon electronegativity will be greater than the magnesium. So whose plus I will be better? MgCH3 will be show better plus I in comparison to SiMe3. Now next we will compare the isotopes. Okay, so what I know that plus I is inversely proportional to the distance, means more the distance plus I will be less. So when I talk about the distance, we can here talk about the bond length. So if you see whose bond length is maximum, CH bond length is maximum in comparison to greater in comparison to CD and then CT. Means what I can say here, that if I talk about the plus side group, so CH will have the, what I can say, that if CH bond length is maximum, it means distance is maximum, means plus I will be less here. So CT will show more plus I in comparison to CD and more plus I in comparison to CH. For example, if they gave you this question, that is that if they want to compare the plus I power of CT3, CH3 and CD3, what I am taking here, that CT3, CH3 and CD3. Tell me whose plus I is going to be maximum, okay, in this case. So I know that the bond length of between carbon and tritium is going to be the minimum. So plus I is going to be the maximum. So plus I will be maximum for CT3. Then what is going to come? CD3. And then what is going to come? CH3. Okay, remember this. Now we will talk about the series from this. So firstly remember that for the plus I power, which is going to be greater? Okay, negative charge species or neutral? So first we have to take the negative charge species, because negative charge are rich in electrons, so they can donate the electrons easily. So first in this series, what is going to come? Negative charge species is going to come. And we have already compared the plus I power of the negative anionic group. Okay, so what was the first there? There was CH2 negative. Then after that NH minus will come. Then after that O minus will come. And then after that COO negative will come. Okay, then you have to take the groups which is having less electronegative, that is MgR and SiM3. Then we know between 3 degree, 2 degree and 1 degree what will be there? That 3 degree will show more plus I in comparison to the 2 degree, and then what it will be 1 degree. Then CH3, then tritium, then deuterium, and then hydrogen. Okay, now let's do this question. What are the questions here we have to do? That first one, we have to talk about the compare the plus I power of this. Okay, so what we have to do here? Compare plus I power. Okay, so let's talk about this question. So we have CH2 CH3, we have CT2 CH3, CH2 CT3 and CT2 CT3. So which will be maximum? Here hydrogens are attached to carbon, here tritium is attached to carbon, here hydrogen is attached, and here tritium is attached. Okay, so which will be maximum? Definitely tritium is going to be maximum than the hydrogen. So it could be either B or it could be either D. But in the second carbon, what is present here? Hydrogen, and here we have tritium. So what will be there? That D is going to be maximum, then plus I of D is going to be maximum, then B. After B, what is coming? That if you see here we have CH2, here we have CH2, same thing. But here you have CH3 and here you have CT3. So after this, what is going to come? C and then A. So this will be answer for this question. Let's do the next question. Which is going to be maximum? Here we have CH3, no. Then CH2D, CH2T. So CH2T is going to be greater than CH2D, okay. Then CH D2, okay. Then we have CHT2, then we have CT3. So remember that CT3 is going to be maximum. Then afterwards, what we are going to have? CHT2, okay. After that, what we are going to have? Because here we have 2 tritium, okay. Here we have 2 deuterium, and but here we have 1 tritium. Always remember that when we talk about the isotope, we have to give preference to the number instead of the distance. So if we have 2 deuterium here, it is going to show more plus I in comparison to the 1 tritium. Okay. So after this, what is going to come? CHD2. After this, what is going to come? CH2T. Okay. Now CH2D and CH3. So what will come here? CH2D, and then at the end what will be there? CH2T. Sorry, CH3. Now let's do this question. What we have learned? That we have to give the preference to the number. Okay, that how many, if deuterium are more in number and tritium is less, so deuterium is going to show the more plus I. So what will be the answer here? That CD3 is going to be greater than the CH2T. Remember this point, that in isotope, in only the case of isotope, so in isotope, give preference to number. Give preference to number. Now we will talk about the minus I effect. So what is basically minus I effect? When the electronegativity of the group is going to be greater than the carbon. Here the group which is attached here is going to be more electronegative than the carbon. What will be there? There will be minus I effect. Okay. So here electronegativity of group is going to be greater than the carbon. So if electronegativity is more, what I can say that this group is going to withdraw the electron and it will have minus delta delta negative charge over it. This carbon is going to acquire the delta positive charge. Okay. Now, if it is delta positive, it is becoming electronegative. So again, it is going to withdraw the electron. Here we have a smaller delta positive. Again, this become more electronegative than the next carbon. So it is going to withdraw the electron. And here we have more smaller delta positive charge. What I can say here, that minus I effect is directly proportional to electronegativity of key element. How I can able to say this? That we know that electronegativity is a tendency to attract the electron. Okay. Or I can say if a group is more electronegative, it has more tendency to attract the electron, which makes that it has more minus I power. Okay. So what I can say that minus I is directly proportional to electronegativity. Let's compare between the neutral group. So here we have NH2, OH and F. Now tell me whose electronegativity is going to be maximum. So we know that fluorine is going to have greater electronegativity in comparison to OH and then NH2. Okay. So what will be the minus I power? That is fluorine, then we have OH and then we have NH2. Okay. Now in the B question, here we have fluorine, chlorine, bromine and iodine. What I know that which is more electronegative? I know down the group electronegativity is going to decrease. Means minus I power will also less. Okay. So fluorine is going to be maximum, then chlorine, then it will be bromine and then it will be iodine. Okay. Let's compare the unsaturated group. What are the unsaturated group we have here? Alkyne, phenyl and alkene. So if you see here that alkyne, here carbon is sp hybridized. Here in phenyl, what is the hybridization? It is sp2. Here what is the hybridization? sp2. So we know that electronegativity of sp hybridized is going to be greater in comparison to the sp2. Okay. So what is here? That minus I of alkyne is going to be maximum in comparison to the phenyl and alkene. Now we have to compare between this phenyl and alkene. So when you see here we have sp2 carbon, again we have sp2 carbon and again we have sp2 carbon. Here you have sp2 carbon here sp2 carbon, then you are going to attach, then this sp2 carbon is going to attach with the hydrogen. Okay. So which is going to be more electronegative? That is sp2 carbon. Okay. So after alkyne what will become? Phenyl. Then after phenyl what will become? Alkene. So when we talk about the unsaturated group, first one is going to be the alkyne, then phenyl and then alkene. Now third one is charged group. That how we are going to tell the minus I effect of the charged group. So we know if there is complete positive charge, electronegativity is going to be maximum, means minus I is going to be maximum. Then partial positive, then neutral, then partial negative and then complete negative charge. So what I can say that more positive charge, more will be the minus I effect. Now let's compare the minus I effect here. Okay. So if I see here NR3 has the complete positive charge. So definitely when I am going to compare the minus I, NR3 will have here the maximum, NR3 positive. Okay. Then afterwards what is going to come? NO2. Because what we have seen, this is the structure of NO2. Okay. There will be formal positive charge here over the oxygen and negative charge over the oxygen. So here nitrogen is going to have the formal positive charge. So after NR3 what is going to become? NO2 is going to become. Here there is complete positive charge in NR3 and here in NO2 there is formal positive charge. After this what is going to come? Either NF2 will come or either NH2. So which is more electronegative? I know fluorine is more electronegative than the hydrogen. So here NF2 will come and then later on what is going to come? NH2 will come here. Okay. Let's do the next question. So in next question what will happen here? That we know that there will be partial positive charge and here will be partial negative charge. Okay. We have done the question of the electronegativity here. So which is going to show the more minus I? Whose effect is more? That A is going to show more minus I in comparison to the B. Okay. Let's do more question. Here remember one thing, that when I talk about these elements, so oxygen is going to be more electronegative than bromine, oxygen is going to more electronegative than chlorine, oxygen is going to be more electronegative than the iodine. But when I talk about the minus I strength of OH group, okay, in comparison to chlorine, bromine and iodine, so always remember that minus I strength of chlorine is greater than the OH, minus I strength of Br is going to be greater than the OH, and minus I strength of iodine is going to be greater than the OH. Okay, remember this. When I talk about electronegativity, oxygen is more electronegative than this bromine, chlorine, iodine. But when I talk about the minus I effect, so what will be there? That minus I of chlorine, bromine and iodine is going to be greater in comparison to the OH. Okay. Now let's compare the minus I effect of OH and OR. I'm taking here OCH3. So what we can think, that here CH3 will act as a plus I group and it is going to donate the electron, and here there will be delta negative. So this oxygen is going to withdraw less electron and OH is going to show more minus I in comparison to OCH3. This doubt you people can have, but this is not the correct concept. What is happening here, that we have OH group and we have OCH3. Okay. So what is there, that this oxygen is sp3 hybridized and here also oxygen is sp3 hybridized. Now here what we have, here we have the carbon chain. We can make the carbon chain like this. Okay. And here also we can draw the carbon chain like this, and there will be OCH3. Now what you will see here, due to presence of this CH3 and this carbon chain, there will be repulsion. Okay, what will be present here? There will be repulsion. Here what it will cause? It will cause the repulsion. Okay. So because of the repulsion, the theta is going to increase. The angle is going to increase. Bond angle will increase. I know when theta is going to increase, we have learned that percentage S is going to increase. And if percentage S will increase, what I can say? That electronegativity of the is going to increase. So electronegativity of this OCH3 group, their electronegativity of this oxygen when CH3 is attached is going to be higher in comparison to electronegativity of oxygen when hydrogen is attached. So which is going to show more inductive effect, minus I effect, that is OCH3. Okay. So whose minus I will be greater? OCH3 will show greater minus I in comparison to OH. I will repeat this again, that what is there? That here we have bulky group, here we have carbon chain and here we have CH3. Here we have hydrogen and here we have carbon chain. There will be no repulsion. Okay, here there will be no repulsion. But in the case of OR, what will be there? There will be repulsion. So because of the repulsion, this group will go away from each other and theta is going to increase. If theta is going to increase, what we have learned, that theta is directly proportional to percentage S character. Means percentage S character is going to increase here, and we know that percentage S character is directly proportional to electronegativity. Means if percentage S character is more, electronegativity is going to be more, and if electronegativity is going to be more, what I can say, that minus I effect is going to be more here. So between OR and OH, which is going to have more minus I effect, that is OR. Okay, OCH3. Let's talk about this question. So what you can think here, that this also we can see the repulsion, but that is not in case of this. Here if you notice, this carbon is sp2 hybridized, okay, and this carbon is sp2 hybridized. So there will be no repulsion in first case, as well as there will be no repulsion in second case. When we will talk about the non-bonding electron pair repulsion, we will see that this repulsion is only caused when the atom is going to be sp3 hybridized, okay, when the atom is of sp3 hybridized, not in the case of sp2. Here atom is sp2. So here also there will be no repulsion, okay, there no repulsion. So now what is there, that this CH3 will going to donate the electron to this carbon. So this carbon is going to have this charge. It is going to acquire the delta negative charge because of this CH3. So delta positive charge in this case is going to be less in comparison to delta positive charge in this case, because this CH3 is going to donate the electron. Okay, so what is happening? Whose electronegativity is going to be greater? Where delta positive charge is more. So what we have seen that in case of CHO, the delta positive charge is more in comparison to C double bond O CH3. So whose minus I is going to be greater? First one, the minus I is going to be greater in comparison to the second one. Now let's compare NMe3 positive and NH3 positive. Same. Nitrogen, what is the hybridization? sp3. Here nitrogen, what is the hybridization? sp3. Here we have Me3 group, means CH3 group. Here we have hydrogen. Here what we have? Me3. Here we have hydrogen. So which will show more repulsion? Me3. Hydrogen, there will be no repulsion. Okay. So here in case of NMe3 positive and Me3 positive, okay, what is there? Repulsion is going to there. So because of the repulsion, theta will increase, percentage S character will increase. That's why electronegativity is going to be increased. So when they will ask you to compare the minus I effect of NH3 positive and NMe3 positive, which is going to be greater? NMe3 positive is going to be greater. Let's talk about the SH and SR. One more thing, that repulsion is not applicable on the third period. It is only going to applicable on the sp3 hybridized and when the element is of second period. Okay, so these are of the third period. So this R is going to donate the electron. So obviously the delta positive charge here is going to be less. So what is there? That SH will show greater minus I in comparison to SR. So what is there? That sulfur is of which group? Third period. So there will be no repulsion. What is the condition for the repulsion for this non-bonding electron pair repulsion? So the condition is that sp3 hybridized, the element must be sp3 hybridized and it must be of second period. If we see here, this is sp3 hybridized and sp3 hybridized, okay, and it is of second group, and here we have CH3. That's why there is repulsion. So because of repulsion, theta will increase, percentage S is going to increase and electronegativity will increase, which will increase in the minus I. In the second one, what is it? It is sp2. So there will be no repulsion. So we have to do by this delta positive. Okay, this CH3 will donate the electron. Here delta positive will be less and electronegativity is going to be less. That's why here this group will show more minus I in comparison to this C double bond O CH3. In case of NMe3 and NH3, what we have? NMe3, here methyl is crowded. Okay, here methyl is going to show the repulsion. Here nitrogen is sp3 and it is of second period. So here there will be repulsion, theta will increase, percentage S will increase and inductive effect is going to increase. Next one is SH and SR. Again, what is there? That these are sp3 but they are not of the second period. That's why SH minus I is going to be greater in comparison to the SR. So let's do some question of the minus I strength. So first thing we have to consider the charge. If it is positive charge, okay, so it is going to be more electronegative and it is going to withdraw the electron. Minus I is going to be more. Then we have to do the halogen. Halogen will show more minus I in comparison to the unsaturated compound. Okay, so let's do this question. First one is we have to compare the minus I strength. So first question is NO2 minus I and OH. So we know NO2 is going to have the formal positive charge, we have seen before. So which is going to show minus I maximum? We have NO2. Now between OH and I, which will show iodine. Okay, halogen is more than the OH. We have seen that fluorine, chlorine, bromine, iodine. These all are going to show greater minus I effect in comparison to the OH. So we have minus I. Here we have iodine and then we have OH. Okay. Let's do the second question. What is second question we have? That we have cyanide, NO2, we have fluorine, we have OH and we have iodine. Okay, so we have cyanide here and we have NO2. So I know NO2, here we have formal positive charge and here cyanide also we have partial positive charge. Okay, if I draw cyanide, I can make the partial positive charge here and partial negative charge over here. But here nitrogen is what? sp2 hybridized. Okay, so what will be there? Nitrogen will come first. So NO2 is going to be maximum. So whose minus I is going to be maximum? That is NO2. Then we have cyanide, C triple bond N. Then between fluorine, OH and iodine, obviously fluorine will come. Then iodine, and then we have OH. Okay. Let's do the next question. We have C triple bond N. We have Nr3 positive, OR and C triple bond CH. So first one is charge species we have to see. So Nr3 positive is charge species. So minus I of B is going to be maximum. Then we have C triple bond N. So here I can create the delta negative and here delta positive. So after B what will be there? A. Okay. Now between OR and C triple bond CH, what will be maximum? I know that oxygen here is sp3 and carbon is sp. Carbon sp is more electronegative than nitrogen sp3, okay? But it is not more electronegative than oxygen sp3. So after this, what is going to come? OR. Then D, that is C triple bond CH will come, okay? Let's do the next question. Again, where is positive charge? Sr2. So A will be answered. Now, what will be there? NO2 or C double bond OH? I know NO2, okay? Here there will be formal positive charge or partial positive charge, you can call it. And it is nitrogen sp2. Here carbon is sp2. So, I know nitrogen sp2 is more electronegative. So, what will be there? B. After this, between C double bond OH and NH2, obviously C double bond OH. Here we have partial positive. So, C. Between OH and NH2, which is more electronegative? Oxygen. So we have D and then we are going to have the E. Let's do the next question. We have CH2, C triple bond CS, C triple bond N and C double bond OH. Okay. So first we will talk about the partial complete positive charge. There is no complete positive charge. Partial positive, yes, I can make partial positive here. I can make partial positive here. Okay. So here it is sp hybridized and here it is sp2 hybridized. So which will come first? Cyanide will come first. Okay. So C triple bond N will come first. So I will write it as that minus I of C is going to be greater than D. Then between alkane and alkyne, obviously alkyne. So it will be B and then A. Okay. Let's do the next question. So between phenyl, alkyne, OCH3 and C double bond OH. Let's see where is partial positive. Here only there will be partial positive. Okay. This is electronegative. These are the unsaturated compounds. What we have learned here? First charge. Then first we have to see charge. Then halogen. Then we have to see electronegativity of the and with the help of the hybridization. Okay. So what is there? So first one is going to be D. Minus I of D is going to be maximum. Then after D what will be there? C. Then after C, what will be there? B. And after B, then there will be A. Okay. Let's do the next question. So we have cyanide, C triple bond N, C double bond OH, C triple bond CH and CH double bond CH2. So which is most minus I effect which will show, which is most electronegative. So here we have delta positive charge. Here also we have delta positive charge. Okay. Now, what I can do here, that between cyanide, here it is sp and it is sp2. We have done this question already. This is sp and this is sp2. So, what I can see here, that A is going to be greater than the B. Then what will come? C and then D is going to come. Okay. Now, how we are going to make the order of the minus I, how we are going to remember. So from this concept, we are able to remember the order. Okay, it is difficult without the concept to remember this order. So to know this concept, to remember this order is very important. So what is the order? First, we are going to take the positive charge species where we are going to have the complete positive charge. So if you see here, that first we are taking the positive charge. So here we have Nr3 positive. What is there? Nr3 positive and then NH3 positive. Okay. So first one is Nr3 positive, then Sr2 positive, then NH3 positive. Then NO2. Remember NO2, then C triple bond N, then carboxylic. Okay. So always remember this, that first one is nitro. We have to see nitro, NO2, then cyanide, then carboxylic acid groups are going to come. After this, halogen will come. Fluorine, chlorine, bromine and iodine. After this, what is going to come? That is OR, C double bond OR. Okay. Then OR, SH, SR and OH. Okay. Then triple bond, then phenyl, and then double bond. Okay, so this is the minus I series. Let's compare the minus I strength of OH and SH group. Okay, so what is here that we know that the electronegativity of oxygen is greater than the sulfur. So from this, the OH should show minus I more in comparison to the SH, but this is not going to happen here. Okay, what is there that we have OH and we have SH. Now which is more electronegative? I know that oxygen is more electronegative, so it is going to withdraw more electron from the hydrogen. So here it is going to have the delta negative charge more. Here it is going to withdraw the electron but less in comparison to the oxygen. So where the delta negative charge is more, that is on the oxygen. So it is going to withdraw the less electron, means minus I of OH is going to be less in comparison to the minus I of SH. Why? Because here there is more delta negative charge over oxygen, because it is withdrawing the electron from the hydrogen. So its minus I effect is going to be less in comparison to the SH. Okay, so what will be the final series? That between OR and OH we know that OR is going to be have greater minus I in comparison to OH because of the repulsion. Okay, between SH and SR, what we have seen that SH is going to greater than the SR. Then when we talk about OR and SH, what we have seen that OR is going to have the greater in comparison to SH. Okay, but SH is going to greater in comparison to the OH. So this is the ultimate series. Now when I talk about the minus I, what are the things we have to keep in mind? So while doing the question, first see the distance. Then you have to give priority to the number of grip, and then you have to give priority to the power. Okay, let's apply this. So when we talk about the first CH2F and CHCl2, if you see here that fluorine is more electronegative than the chlorine. But what I have to consider here, before power, I have to consider the number of group. So if you see here, we have only one minus I group, but here we are having two minus I group. So which is going to show minus I effect more? That will be B greater than A. Okay, so minus I of B is going to be greater than A. Now let's talk about the question number 2. So if you see the minus I group, that is chlorine here, and here it is fluorine. This chlorine is attached at carbon number 1. Okay, this is attached with any parent carbon chain, any chain, and here it is attached with carbon number 2. So where the minus I will be maximum, where the distance is going to be less. I know that minus I is inversely proportional to the distance. So where the distance is less, in the case of A. So minus I of A will be greater than the minus I of B. Let's do some more question. Let's see this question. So what we have to see for the minus I? First distance, then we have to see the number, and then we have to see the power. Okay, so first see the distance. Here 1, here it is 1 and 2, here it is 1 and 2. So which is nearest? This Cl is nearest. Okay, so on the basis of the distance, minus I will be maximum for the A. Now compare between B and C. Between B and C, distance is same, so I have to see the number, not the power. Okay, so whose number is greater? Chlorine number is greater here. Chlorine, we have 2 chlorines. So what will be here? Then B, and then what is going to come? C. Okay, let's see the next question. This question. So first we will see the distance. Here 1, 2. Okay, here fluorine, here minus I is at second carbon, here fluorine is at first carbon, here 2 Cl is at first carbon, here 1 NO2 group is at first carbon, here 2 fluorine are at first carbon, and here 3 fluorine are at second carbon. Okay, so in which we are having the minus I group at the first carbon? In the B1, in the C1, in the B1 we have, in the C1 we have, in the D1 we have, and in the E1 we have. Okay, now we see the number. Here we have 1, here we have 2, here we have 2, and here we have 2. So 2 are in the C and E. So we will first compare between C and E. Okay, so between fluorine and chlorine, which is more electronegative? I know fluorine is more electronegative. So first E will come, then later on what is going to come? C will come. Okay. Now between B and D, I know that NO2 is going to be more electronegative. So minus I is going to be higher. So then D is going to become, and then B is going to become. Now on second we have NO2, on second we have fluorine. But in case of F you have 3 fluorine and here NO2 is 1. So after distance there will be number and then power. Okay, after distance you have to see the number and then power. So after this what is going to come? F and then A. So this will be the answer for this question. Let's do this question. What we have here? Okay, if you see A and C, there is complete positive charge. We have NH3 and we have NCH3 whole thrice. So here what we have learned that NR3 positive is going to show greater minus I in comparison to NH3 because of the repulsion. The theta is going to increase, percentage S will increase, and electronegativity is going to increase there. So first is going to be C and then A. Let's compare the B and D. I know that there will be partial positive charge over the carbon. We have done this type of question previously. So B and then there is D. Okay. So this type of question will be asked from you. To tell that which will show the minus I effect more, you have to compare the plus I effect, you have to compare the minus I effect. There is another type of question where you have to show the direction of inductive effect. This question is directly from your sheet. So what we have here, that it is sp hybridized. Okay, what it is? Sp hybridized, and this carbon is sp2. So tell me which is more electronegative, sp or sp2? I know sp, so the direction will be towards this. Let's do the second one. We have CH3, CH2, CH2 Li. Li is what metal? So lithium is going to be from the positive. Okay, lithium will have positive. So here CH2 will have the negative charge over it. So if it is negative charge, it is going to be less electronegative. This carbon neutral is going to be more electronegative. So it is going to withdraw the electron. And again what will happen? There will be partial positive charge. Again this will going to withdraw the electron. Okay. Let's see the next. Here we have C double bond O. Okay. So here we have delta positive, here we have delta negative. If it is delta negative, here we have delta negative. Okay. So if it is delta positive, this CH3 is going to donate the electron towards the delta positive. Okay. Now let's see question number this. Here we have positive charge on the center carbon. Okay. So what will happen? This carbon is going to donate the electron, this carbon is going to donate the electron, and this carbon is going to donate the electron. Here we have MgBr. Again magnesium is a metal, so it is going to acquire positive charge. Carbon will have negative charge. So it is going to donate the electron, and this will also donate the electron. Sixth one, what we have here? NH3. NH3 is positive, so it is going to withdraw the electron. Okay. Now this CH3 is plus size, and here it is sp3 and here it is sp2. So sp2 is going to withdraw the electron from the sp3. So that's all for the inductive effect. In next lecture we will talk about the resonance. Thank you everyone.